Hi, everybody. Last time we saw each other a long time ago, we were doing 4.12, working in the Dynamics Unit, Section 12, and we were talking about multi-body systems. That is a dynamic system, and that means a system with forces with two or more objects in that system. Now, those systems are generally connected by things like ropes or cords, and that's exactly what we saw. We did one question where an object was connected over a pulley, right? Now, I'm going to show you the notes here. Don't be concerned if you don't have your notes with you. You don't really need them. I'm going to show it to you in a moment. But this is the section that we were working with. Okay, here we are in this section here. Question B, where we were working on. What I'd like you to do is I'm just going to move myself down. There we are. What I'd like you to do is, there's two objects here. We'll call it object 1, which is a 10 kilogram object, and object 2, which is the 5 kilogram object you can see right here. What I want you to do is draw two free body diagrams, one for each of these objects, including all the forces that act on each object. Now, for object 1, the 10 kilogram object, there will be a force caused by this rope. That tension force in that rope will be different than the tension force in rope 2 over here. In fact, we're told that the tension force in rope 2 is 100 newtons up here by the question. So draw two free body diagrams, and you can pause this video while you're doing that. And once you've completed drawing your two free body diagrams, you can resume the video, all right? Okay, so you can see I've drawn two free body diagrams here. The first one over here is a 10 kilogram object. It has a force of gravity pulling down and an equal but opposite normal force. I know those two are balanced because it's not moving up or down. Then there's this tension 1, pulling it to the right, and that's opposed by a friction force as the box slides across the ground. Object 2 over here is a 5 kilogram object. It again has a gravity and normal force which are balanced. I calculated the gravity here, and it's equal to the normal force. It is pulled across to the right by a force of tension on a different rope. It's a physically different rope than the first rope I spoke about, and so I've given it a different name, force tension 2, FT2, and we're told in the question that that's 100. So automatically, I know that value. It's opposed by a tension 1, that's the rope attached to the other object, and a friction force, all right? Now you can see for both free body diagrams, I also calculated the friction force in red here for each object. Now what I'm gonna do is I'm gonna calculate the net force for the whole system so I can calculate the acceleration for the whole system, all right? So here we go. Oops, let's try getting a pen. F net for the system. I put a little S to remind myself that it is in fact the whole system that I'm dealing with. And any force pulling either object to the right, which is the direction it's going to move, will be a supporting force. So that'll include force of tension 2 and on object 2, and force of tension 1 on object 1. Opposing forces will include all the forces that oppose the movement to the right of the diagram. So that's going to include force of friction on object 2, the force of tension 1 on object 2, on object 1, it's going to include the force of friction. Now what you'll notice here is we are adding the tension 1 here and then subtracting it as an opposing force. So right off the bat, that cancels out. Let's put in the numbers. Tension 2 was 100. Force of friction 2 was 4.41. And force of friction 1 was 8.82. Okay, so let's pick up a calculator and run that calculation. 100 minus 4.41 and I subtract again 8.82. That gives me an 86.77 net force. Okay. Now, as you all know, net force leads to this equation, F net equals ma. And this is the net force for the system, so we're about to find the acceleration for the whole system. Acceleration then is going to be equal to that F net. Now let's, in fact, in doing that, let's put the numbers in first. 86.777. And the mass is, for both objects, 10 plus 5, 15 kilograms. Find the acceleration. Okay, so 86.77 divided by the 15. That's going to give me a 5.785 meter per second squared acceleration. That means both objects, A and B, are accelerating with 5.785 meters per second squared to the right. Okay, so that's one of the things we were asked to find the acceleration. The other things we were asked to find was find the tension in the ropes. Well, we already know tension 2 is 100. So let's find tension 1. Now to do that, I'm going to look just at this object. Right? You could solve it for this one, but this is a slightly more simple diagram, so let's pick this one. M1 has a force tension 1 and a friction force. Those are, the tension 1 is supporting, the friction force is opposing. So we're now going to use the acceleration that we know M1 has, and we're going to apply it just to this object, not the whole system, single object only. Because remember, the point of this section of notes is to know that you use the whole system, all objects, to find the acceleration, but you use a single body analysis to find a force. So we're going to find force tension 1 now by just working in object 1. So over here, F net is equal to mass times acceleration. Now object 1's mass is 10 and the acceleration is 5.785. That's 57.85 newtons. F net is equal to forces supporting minus forces opposed. Supporting force for F1 and just F1 is force of tension 1. Opposing is friction. Now, we know that force tension 1 is unknown and friction is 8.82, so let's put those in. And F net was 57.85. Okay, so what we have here is, let's solve now for force of tension 1. I'm going to add the 8.82 to both sides. That's 57.85 plus the 8.82, and I get a 66.7 Newton force for FT1. And I already know that FT2 is 100. So that's how I solve for the two forces here and the acceleration. All right, next time I see you, which will be lesson 2, we'll be talking about momentum, a new topic, which is not that difficult. So I'll see you next in lesson 2.